Have you ever been stuck trying to move an element into a vector of non-copyable types, only to be met with a frustrating compiler error? If that's you, you're in the right place. Today, we're diving into the world of C++ and tackling this tricky issue. I totally get how annoying it is when you think you've written perfect code, only to have the compiler throw an error at you. You're not alone in this struggle. Many developers face similar challenges when dealing with non-copyable types in C++. Let's look at the specific question at hand. One user asked, "Why can't I move an element into a vector of non-copyables?" They shared a snippet of code that uses a lambda expression and a package task, but they encountered a deleted function error. Sound familiar? Let's break this down together. So what's going on here? The issue arises because the lambda expression captures a non-copyable type, which leads to the compiler trying to use a deleted copy constructor. This is a common pitfall when working with lambdas and non-copyable types in C++. And stick around. At the end of this video, I'll share a pro tip that can help you avoid these kinds of errors in the future. To address the user's issue, we first need to understand why the lambda expression cannot be copied. The user is trying to store a lambda that captures a non-copyable type, which leads to the error. Next, the user should consider using a shared pointer. By using a shared pointer, the lambda can capture the task without needing to copy it. This allows for proper memory management and avoids the deleted function error. Now, let's modify the lambda expression. The user should update the lambda to use the shared pointer, ensuring that it can be safely moved and invoked without copying. Finally, the user can test the updated code. By running the program again, they should find that the error is resolved, and the lambda can now be successfully placed into the vector. Fun fact. Did you know that C++ was originally designed to add object-oriented features to the C programming language? It has come a long way since then, but some of its quirks can still trip us up. Now let's look at the answers provided by other users. This user explains that the issue arises because the function type used in STD function must be both callable and copy constructible. However, STD package task is not copy constructible. Therefore, when the lambda captures the task, it creates a non-copyable member, which leads to the deletion of the lambda's implicit copy constructor. That's all for that response. Let's see what someone else had to say. This user explains that lambdas and STD package task are not STD function types. They point out that you cannot move a STD package task into a STD function directly. As an alternative solution, they suggest using a vector of STD package task instead. This allows you to place the task directly without issues. If you need a STD function, you'll have to bind a lambda into a STD function explicitly. That's it for that response. Let's explore another one. The user explains that the issue arises because STD function requires its contained function object to be copyable. However, STD package task is not copyable. They outline 3 approaches to handle this: forbidding copying, allowing copying but throwing runtime errors, or requiring all function objects to be copyable. The third approach is the one that was standardized, but the user has created a unique function class template that forbids copying, as their use case often involves non-copyable asynchronous tasks. Here's that pro tip I promised. Always consider using smart pointers when dealing with non-copyable types. This can save you a lot of headaches and make your code cleaner. And there you have it. You should now have a better understanding of why you can't move an element into a vector of non-copyables and how to fix it. If you found this video helpful, please subscribe for more tips and tricks on C++ programming.